Stylized graphics are becoming an increasingly appealing art style in video game development. Creating non-photorealistic rendering with the power of shaders can help give your project the spice it needs to stand out, especially in the current market that is drowned in thousands of small indie games and big budget titles. However, there is one small problem. Shaders are hard, not just to make, but to understand in general. With all the complicated names, processes, and maths required to create decent looking shaders, it can be overwhelming to even start creating stuff without clinging to tutorials closer than to meet at the pokies at a Saturday night. That's what this presentation is for, to help people like you better understand some of the techniques and tools commonly used to create stylized shaders in video games and other projects. For the sake of an example, let's also try to create Silver Age comic book stylization, as recreating this art style will require a variety of common techniques that are used in games. I will also be focusing on Unreal Engine, as that's the engine I'm most familiar with when it comes to shaders, although most, if not all, of the techniques here can be replicated using other engines. NPR is a blanket term used to describe rendering that isn't realistic, i.e. anything that isn't AAA slop. This style of rendering is generally a result of an artist wanting a specific look as opposed to using a pre-made or otherwise easy to use lighting model. For this reason alone, the first step for creating anything stylized is to do your research. Often when you start making shaders for games or other projects, you're going to ask yourself questions you didn't even realize you would ask, such as how metallic surfaces work, why those edges don't look quite right. As a beginner, a good strategy to make anything is to find a style you like and try to recreate it in your preferred engine. As an example, I'm going to do this comic shader. However, I want to make this metallic that Marvel does all the time in the 70s, because something about the way that metal looked just scratches an itch in my brain. One thing you'll notice right away is that this is not how metal looks in real life. Welcome to NPR, we hope you enjoy your stay. But rather, this is a clever way to describe a rather shiny or chrome finished metal given the limited methods comic artists of the 50s and 70s had to work with. Silver Age comics use the same ink that printers today use, that being CYMK colors: cyan, yellow, magenta, and key black, a method that is fundamentally different to computers which use RGB, red, green, and blue. This means that when you add up colors on a printer, you get black, and on a computer, you make white. Mixing colors on a printer is also different, as to make colors, you must place the ink in specific patterns, which minimizes overlap and allows your eyes to mix the color themselves. On top of this, newspapers and printing agencies also placed a limit on the amount of colors artists had access to, almost always only around 64 colors to cut down on costs, prevent colors from becoming either too similar or an ugly brown when it was mixed, or to just simplify the process for printing. These color keys were printed out as reference sheet and given to artists as a base to make comics with. This limit almost never mattered though, as many artists only use half the colors, which contributed to the bold, vibrant, and simplistic shading that defined this era of comics. Going back to the Ultron image, we can see these restrictions in full effect. The printing methods create these iconic Ben-Day dots, an artifact from the circular pattern the printers made. The limited palette is also demonstrated here, with only a couple of colors used to make the chrome, energy effect, background, and outline. To make the image appear more metallic, there is a striking contrast created by the white fill and the black outline which emulates real-life chrome metals. There is also crosshatch shading in the image, mostly to indicate where the metal curves and to help create depth, as most of the shading is harsh and simple. With this in mind, we can go and create a shader that encapsulates these elements. Since we're working in Unreal Engine 5, we must make an important decision as to what type of shaders we are making. While there are many types to shaders in Unreal Engine, the two most important for this video are regular materials and post-process materials. Regular materials are applied to a single object, often as texture maps, fancy effects, or master materials, a technique where you create the framework for a material and fill in the blanks later on for different objects and scenarios, often as a material instance. Post-process materials are the inverse. They are applied to the entire scene, often requiring an override for objects that don't need to be affected by the post-processing. These materials generally contribute to the style the most, as they affect everything in the scene unless explicitly told not to. In essence, the difference boils down to what you want to be covered. If you only need to put one material on an object, use a master material. If you want to shade an entire scene with a specific effect, use a post-process. Both have their purposes, but for the sake of example, I will be utilizing both. Whilst most of the chrome material will be made using a master material, the Ben-Day effect will be made using a post-process, as I wanted it to affect everything, similar to how it looks in the Ultron image. Now onto the shader itself. I started by creating the post-process material so we can develop the overall image and get a better idea of how we're going to make the chrome material. I don't want any realistic effects in this shader, so I'm removing the motion blur, vignette, and sharpness, giving this shader an overall cleaner and more stylized feel. I also wanted the image to be brighter and a bit more vibrant, so I increased the vibrancy of the overall image with gain. Inside the shader, we'll need to create a texture for the dots. I personally just made one by grabbing a circle texture and blurring it out so we get a good gradient. This will be for saturating the texture so it will be fully black or white, so we can adjust the size of each dot as is. In order to create this array of dots, we'll multiply the UVs by a set amount so we get a large grid. Unfortunately, the grid gets stretched out due to the aspect ratio influencing the UVs, so we'll have to account for that by finding the average of the X and Y of the screen itself. We can now properly start working on the Ben-Day effect. Firstly, we'll need to separate the grid into separate colors. As mentioned earlier, the dotted grid in Silver Age comics was placed in a very specific way to best mix the colors. In this case, each color was rotated by a specific degrees. 15 for cyan/blue, 75 for magenta/red, 0 for yellow/green, and 45 for black. We can achieve this effect by grabbing a rotator node, inverting the degrees we want to divide by, and plugging it into the UV scale function we created. When plugged into the dotted shape, we can start to see the basis for the shader being created. We'll also need to saturate the dots to make sure they're perfectly round so we can mask out the dots from the background. We'll grab the rendered image and then mask and desaturate it. whilst making the fractional amount left over the only part left to clean up the dots. I inverted the output and made a separate function node that deflates the size of the dots by an arbitrary value to get the desired shape we want, then subtracting all of that from the dots array to get the final effect. The image doesn't come out very clear though, so we'll divide the result by a tiny amount to increase the brightness of the image overall. Since we want to create multiple arrays of dots, we'll have to duplicate the process 4 times, one for each color, and to rotate by the specified amount. To make them all render at the same time, we'll append each value to one 4 vector and multiply the base color back into the image to remove any other problems with the color itself. While this look isn't perfect, it still looks like the classic Silver Age images, especially with some basic models. However, I still want to replicate the reflective metal that Ultron has, so we'll create a master material that allows us to adjust the reflectiveness, including the color, amount, and width of the outlines. I started by creating a custom Fresnel, a function that basically detects the angle of the faces for an object you can see. The closer they are to the edge, the more it glows, useful for creating outlines and other reflective effects. We can add a power, subtract, and multiply node to the function to edit the strength, coverage, and intensity. When we invert this Fresnel, we get a mask that can be interpreted between, so we can adjust the interior color and the reflective color. I personally also made a model with textures for this project, so I added that to the lerp function to get the first step of our metallic effect. To help increase the more natural line work that artists create in the comics, I also multiplied the Fresnel mask by pearl and noise texture, which gives the outline a more natural and uneven feel. I also wanted to add the black ring to the shader, so I duplicated the Fresnel to get a black outline. I changed all the Fresnel edit values to parameters here to allow us to modify the shader much easier with instances. I made sure to name the edge line and intensity the same parameter for both, so that they're taking from the same value. But the strength value was changed so we can adjust the amount of black sheen we want. When we lerp between the black, white, and coloured layers, we now get a shader that looks pretty similar to the chrome metal, but we're still missing the crosshatch curvature that was integral for creating depth on Ultron. I created another custom Fresnel, but this time, instead of changing the shape and density of the outline using numbers, I used an if function, which gives us a more precise threshold for which the scratches will render. I then created the scratched texture by placing jagged lines in a crisscross pattern and multiplied its UV so we can adjust the size of the scratches at will. We then simply add a threshold to the if function so we can mask out a specific ring of the object. If we finally lerp this node into the shader once again, we can finally use the shader in all of its glory. What's more important is that we can create instances that can be adjusted to fit different models. I downloaded some other ones to show what this one can look like just by changing the values in the instance itself. Finally, I created a brand new material that can be overlaid onto models for an outline. We'll need to invert the normals of the model, then inflate that to create the outline using backface culling. When we plug in a color to the base and emissive, we apply it to the model and finish the comic effect. I'm very happy with how this has turned out. Being able to create this metallic shader has more potential even outside of just this sort of stylization. We could potentially code it in a way to change the colors of the outlines or the texture of the scratches to apply status effects or different emotions. This shader could also be used as a basis for creating more complex comic book styles, similar to the Spider-Verse movies. The limit is basically your imagination. One of the most important threads of stylized art is creativity and intention. Throughout every bit of research I did for this video, every artist always had a striking connection. They had a unique idea in their head, and they wanted to see it on screen. Often, it's way too easy to lose sight of your awesome, interesting shader idea when you're knee-deep in ray tracing calculations and figuring out normal vectors. Frankly, I'm no different. Even though this whole video can just be viewed as a passion project aimed at trying to make a super cool art style in a video game engine, and in some ways it is, I found myself bashing my head into the wall trying to figure out the right way to design a post-process effect without wanting to rip your eyes out from how ugly it looked. But I realized this. As you create, you tend to understand things better. You tend to get better at making it. You'll look at a piece of code and think, wait, I know why that's there. Sometimes you'll nail exactly how someone created that cool art style in your head, and you'll begin to appreciate the work putting that creative, specific, super interesting, cool and fun idea that anybody with a brain can look at and think, that's awesome. I want to leave you with the words of Junior Christopher Motomura, the lead character developer and technical artist at Arc System Works, who had this to say about stylized graphics.
I want to see more studios explore non-photorealistic rendering. I feel that not enough research has been put into this area, and there's much more room to explore and improve. Photorealism is great, but it's not the only route. It's a crowded one too. If you look in different directions, there's a whole new horizon. You could be the pioneer that gets there first. The frontier is there, waiting to be discovered.
So, what will you create?